Hello again. In this screencast we're going to be doing an example of the problem 3 from week 10 MStatsLab homework. In this problem, a supermarket chain wants to know if their buy one get one free campaign increases customer traffic enough to justify the cost of the program. They select 2 random days to take a traffic count, and they have 10 stores that they're going to use. They want to test the hypothesis that there is no mean difference in traffic against the alternate hypothesis that the program increases their traffic flow. So part A of this problem asks us, are the data paired? And my statement here, I say that data are paired when the observations are collected in pairs, or when the observations in one group are naturally related to observations in the other. And of course this data is related because we're looking at running traffic counts with a buy one get one free program against the same stores, the traffic data of traffic without the program. So we move on to part B, and part B asks us to find the mean difference. Well, to do that, I list all of my data here, stores 1 through 10, and the traffic counts. And I first find the pairwise difference. Click on my cell here, you see I did C8 minus D8, so I'm finding the difference between the two traffic counts. List my sum, our answers here, difference between column C and column D, total here, which is the sum of all of these, but it asks us for the mean, so we know the mean is the average. So in this cell here you see I have equals average E8 to E17 of all of our data, so the average or the mean of these is 0.9 or negative 0.9. So that's our mean difference. Moving on to part C. Part C asks us to compute the standard deviation of the differences. And for this we need to know the sum of the squared differences. So my next column here shows D minus D bar squared. Click on my cell here, you see I have E8 minus $E $20, and I'm squaring the total amount. The reason I use the dollar signs is because I want to use the absolute value in this cell, and it will not change as I copy and paste down my column. So each time I move down, it's going to say E9, but still using our mean here of 0.9, negative 0.9. So we find D minus D bar squared, and then we sum up this column, and we get 236.9. So we can go to our formula for our standard deviation, and we put in the square root of F18, which is the sum of the squared differences, divided by 10 minus 1. We have 10 stores, so 10 minus 1 is 9, so 236.9 divided by 9, the square root of that is 5.13, so our standard deviation is 5.13. So now we can move on to part D. Part D wants us to compute the standard error of the mean difference. So our standard error formula, D25, which is our standard deviation that we just calculated, divided by the square root of C20. C20 is our 10 stores, so D25, our standard deviation 5.13, divided by the square root of 10, and we get our standard error to be 1.62. Moving right along, part E. Part E asks us to find the value of the t statistic. Now remember that our null hypothesis says that there's no change, so we're going to be using 0 in our formula here, and you see E20 being our of negative 0.9 minus 0, because there is going to be no change, divided by D29, our standard error, and we get our t-stat to be a negative 0.555 once we round it. Okay, pretty good so far, huh? Part F. How many degrees of freedom does the t-statistic have? Well, we have 10 stores, so 10 minus 1 is going to give us 9 degrees of freedom. Part G of this problem. Is the alternative or a one or two-sided? The store is testing to see if traffic increases, so this is a one-tailed test. So the alternative, is it one or two-sided? And we're saying, because we want to know if traffic increases, that this is a one-tailed test. And part H, it asks us to calculate the p-value. So for the p-value, we're going to use our t-dist. We have to have 3 pieces of information. We need to know our t-value of 0.55, our degrees of freedom of 9, and this is a one-tailed test. And here's our p-value here, calculated. And we can move on to part I, the last part of our problem. And it asks us at an alpha of 0.05, what do you conclude? Well, our p-value is greater than 0.05, so we will not reject the null hypothesis. Well, there you have it. That's problem 3 example there. Pretty long problem there, isn't it? But using Excel, we can take care of all of this fairly quickly. I hope this helps you calculate and finish problem 3 in your homework. See you next time.